This is Defensive Instruction for Justin Shahbaz, September 2nd. So the lesson started. We have a pacing guide here. This is sort of all tagged up. But anyway, quarter one benchmark. So we have all these specific learning targets to get through by the time we get here. Given that, my choices were to organize the learning targets according to the units that were given to me by the Math and Science teaching program at Loyola Marymount, and then those serving as the basis helped me create my actual instructional plan, which can be seen here. It's a block plan format. We have the content, the learning targets, according to the pacing guide that I previously mentioned, and focus questions for each one. Each lesson comes with an engaging hook, followed by an investigation, followed by interactive mini-lecture, which is then followed by active practice, which then culminates in an exit slip to assess student learning. The research behind this hooks are in order to attach emotion and make associative memory connections, and that comes from research by Edward Reddish at the University of Maryland and Allen and Bacon. The particular hook that I did for this lesson was to have them talk about roller coasters. We watched a video about roller coasters. Data there, 75% of my class has been on a roller coaster, and they're familiar with Six Flags. Actually, 100% are familiar with it, but 75% have actually been. And all of them will go at the end of the 8th grade year. So it's a good talk. I mean, it's relevant to their life, which is important according to that research. The IBE required multiple representations of specific. Here we have the hypothetical situation was that each one of these represented a different vehicle, and each vehicle carries 2 adults and 3 kids, or 2 adults and 5 kids. So they just had to represent each situation through a variety of representations, basically. So either you write it here, number of vehicles, pictorial representation, symbolic representation, and the number of people. So students had to jump back and forth between different representations of a problem. And this is supported by Van Huebelen as a need to investigate. From here, we had a short discussion. This is the Justify, Think, Pair, Share was on the last one, which is think about it, 3 cars go, but then an SU would bring some people back early. So here the justification for the Think, Pair, Share is to allow students to have more of an in-depth discussion on this thing. And that sort of comes out of the same research for, as far as I know, it's from the same research as active practice, the idea that students can't just listen. They have to read, write, and discuss, and that comes from Chickering and Gamson. The interactive mini-lecture was, it's Cornell structured, and there's a series of examples at varying levels. So here the research is about interactive lectures. That comes from Murphy and Sharma. That's a School of Education at Nottingham. And they suggest that in order to be engaged, in order to increase engagement, we have to allow plenty of opportunities for students to interact. So here I'm using plenty of formative assessments at each level, or at each step of the notes. The active practice was followed. Oh, I'm sorry. There's actually, over here, there were some brain bubbles that were to be inserted in the notes about adding the opposite and combining like terms and how to do that effectively, just to address misconceptions. And then from there, they went into active practice with my resident. The gallery walk itself, there are answers posted up around the room, so students were required to work out their problems in organizers, discuss them with each other, and then compare their answers with the board. This ended in an exit slip here, where I could then assess student learning, and this is supported by Marzano. The Marzano research suggests that it's best to have students engage in frequent assessment. Now, How do those teaching practices achieve that outcome? I mean, I think I've already discussed that. The data collected during the lesson during the hook and the IBE, just by visual survey, I could see that student data, student engagement, basically was very high, 90 to 100%. As you can see from my room here, I have the students in groups, and then the smartboards here. So as we work through them, it's I navigate through to each group. I see how they're collaborating. They had an organizer for the IBE to make basically a formative assessment very easy as they work through it. And I also had another teacher in the classroom, Ms. McKinley, science teacher, also observing for me, and she confirmed that it was about 30 out of 32 engagement for both the hook and the IBE. Engagement did fall during the think, pair, share, possibly as a result of maybe miscomprehension of the question. So, so here I decided to explicitly teach that concept, and then that discussion then raised engagement once more, but I don't really have data specifically on that other than, once again, visual surveys. I didn't have whiteboards there. Into the lecture, when we got into the interactive mini lecture and discussing how to do these specific problems according to these steps, I did an I do, you do format. So some of these I did on my own, and then I would have the students discuss with each other and then come up with the steps for resulting problems. Frequent surveys of student understanding inform next steps throughout interactive lecture, and students write in their notebooks. They each have their own notebooks here. So student notebooks are where the students keep, obviously where they keep all their notes. They have a table of contents, and everything is organized according to a Cornell note format, here and here. And like I said, and then formative assessment is weaved throughout the mini lecture in order to make it more interactive. This particular student has like a set number of examples, but whether they were just copying them or whether they were really useful, I can't really determine at this moment, so I don't really have data specifically on that. The exit slip data is here. It's basically split into two groups. From what I saw is that some students were still struggling. It was about 50-50 between the two groups. This pile here, these are students that were proficient or very close. So here are the 3s and 4s, and then here are the 1s and 2s, and it's about a 50-50 split. I think I got about 15 and 15 for each side. So because of that formative assessment, looking back, I think that during the lecture, I would probably use a more reliable assessment of student data, like whiteboards, just to check for accuracy, because students would be able to copy down perfect notes with detailed steps and not really find them useful. And the only way I can know that is if I require some sort of demonstration, some sort of visual display that I can actually check. Unintended positive or negative outcomes of my lesson. Positive students are in a habit of showing reasoning. As I can see from a lot of the exit slips here, students are writing their reasoning down. They are showing, some of them, the 4s at least are giving me specific properties that they're using. Here it says given, commute, and simplify. Here it says given, distribute, and simplify. So the kids are being specific about which properties they're applying in each step, which is positive. On the negative side, I still have, most of these 1s and 2s are like terms and notation problems, which I guess were not adequately addressed in the notes. What elements will you incorporate into the structure of your instructional design? I would definitely incorporate more scaffolding in the IBE, and then definitely more interactive whiteboards during lecture.